All right, so just to kick us right off, those of you had a chance to see it, I generally break networks up, this network analysis up into these two broad areas of ways of thinking about networks. And one is a connectionist approach, and the other is a positional approach. And the main distinction here is what the network's doing to the actors. And so if you think about what a connectionist approach is, it's treating networks as pipes. And this has been the foundational sort of way of thinking about diffusion in networks for a long time. It's probably the archetype way of thinking about networks in the physics for network science world. The networks matter because they create links between things, and those links carry something from one point to the other. And so that's the main sort of purpose of it. There's a wider tradition in sociology and structural anthropology that has to do with networks as patterns. And so the idea of networks with patterns is that by virtue of occupying a particular pattern in the network, that creates a set of incentives and structures that guide how people behave. And so the root of this, like I said, for those who are really interested in getting down the history of social thought on this, is coming out of Nadel and Nadel's work on the coherence of role systems. And this is building out of a whole world around structural anthropology and such, that intuitively, if you've never read any of this model, it says that if you think about what social systems are, they're really hard, right? They're really hard and complex, and people are basically stupid. So it can't be the case that we live in a world every day that's that hard and complex, and people are that dumb and have it work out together simultaneously if there isn't some simplifying feature that makes it possible. And that simplifying feature is roles. Roles are ways for us to categorize the messiness of the world around us to make it possible to abstract what we're supposed to do with simple rules as opposed to, person-specific rules. So I don't have a different rule for every person I cross on the street. I have a role for, I have a notion of how I pass on the street.
Jim, I think you accidentally muted yourself.
Unmute. Thank you. So anyway, those roles are ways for us to simplify the world around us. And more than that, if society were just a jumble of roles, then that wouldn't work either, because roles would conflict. And so in fact, there's a natural coherence to role systems that comes about, that by virtue of having one role, that implies a constraint on the next set of roles. And so you end up with these multi-relational systems and multi-role systems that provide a way to simplify the underlying ways in which the world works. It's kind of like you can imagine, for those of you from literary theory sort of ideas, is that we have a role, and a role system is like a genre. There might be 1,000 different fantasy fiction stories out there where, fanciful creatures find their way through trials in the woods, but they're all essentially the same. So romance novels different from science fiction novels, that differ from horror novels, not because of the content of the character, but because of the arc of the story, and that's what a role is. So that's more social science than probably most of us want. And if you want to get into that, you can go back a little different. The way I like to present it intuitively is this notion, this little graph. Many of you have seen this before. As you imagine 5 actors, you have 2 of whom share romantic love, and those who share romantic love with each other feed 3 critters that bicker with each other. And so, this is an archetypical sort of sitcom family in which hilarity ensues, but we understand this because of the regularity of these relations. And the reason it's important for us in networks is that you can induce the role position by virtue of the pattern of relations. You don't actually need the names to understand the positions. They emerge as a set. And what I've outlined in this particular presentation was that this block modeling approach to it is the traditional way of thinking about it. You have parents versus children. But a position can actually be thought of as mapping onto any characteristic of the network, so long as we can regularize it in some way. And so we have a continuous version, which we typically think of as centrality and have often been defined in terms of flow systems. So you would think that most centralities are actually connectionist problems. But in fact, to the extent that they capture regularized patterns, they really are just this variance of the same kind of thing. And so, for example, you can imagine a notion of leaders as being operationalized as nodes with lower network constraint, for example, or you could think of social butterfly as nodes that change relations frequently. This is one of Mason Porter's ideas. And so there's a lot of these things where you can map a pattern of relations on the network, either static or dynamic, onto a piece, and we tend to call that centrality. And then the alternative version of this is a collective property, which is where we're trying to identify a set of all people that have something in common, and by virtue of their patterns. And so, again, thinking about this in the substantive sense, the set of all people that can hire faculty or deans, the set of all people who descend from the king or heirs, right? So some of these sets are much bigger than others, right? But the idea is that they're there. And you might be tempted to think of this as a community detection problem, and it is a community detection problem in a very special way, which we'll get to in a minute. But roles and positions differ from communities in a couple of important ways. The main one is adjacency, is that the idea of a classical community in network studies is that a community is a set of nodes that are very likely to be adjacent to each other, or at least to have neighbors in common, right? So they have this idea of tight-knit, high density. And that's not necessarily true with roles. So vice presidents might have no relation with other vice presidents, but they're all exactly equivalent in that sense. And the second is that roles, particularly if you take this Nadel ideal of the coherence of role systems seriously, roles have a compounding relation. So my brother's child is my niece or nephew. And so that compounding is a feature of the positions, where you can take a two-step walk through different positions, and that's meaningful as a third relation to ego, which is not necessarily true, not usually true, I think, with communities. So then in the presentation, I talked through a few rubrics or ways of categorizing these and thinking about them, and I'm happy to go over those again. One with respect to centrality, and then another with respect to clustering. The one thing that I would highlight that I didn't spend a little time there is that whenever we start thinking about this various and sundry centrality measures, we tend to focus on a single one. And if you're going to take this position measure, this position notion seriously, then centralities are probably better thought of as collections of nodes. There's node centrality. So the fact that what makes a position unique is not that I have high betweenness, it's that I have high betweenness and low degree. And that makes me distinguished, that makes me different from someone who has low degree and low betweenness, for example. We then talk through the various ways in which you do block modeling. I'm happy to talk through the details of that if people are interested. The main thing to keep in mind is that at the end of the day, what you're trying to do is operationalize these various definitions of equivalence. And I'm not going to go through them in detail this morning. It's all in the lecture, and people are, again, I can do it in Q&A if people are interested in. But at the end of the day, I've tried to propose two different ways of doing it. One is focusing on this role equivalence idea using triads. And the idea there is that these nicely capture local interaction patterns, which is what we're trying to get at. And so if you can identify people's vector of involvement in all possible triadic relations, then you can find people that are similar. And once you find people that are similar in that involvement, that nicely induces roles. This is not my idea. Ron Burt invented this in the 90s. But it's a really nice way to do this that is much more efficient than doing something like the original reggae REGE algorithm that was used for regular equivalence. Let's skip this one. The other insight that comes out of that is that what this is really playing off of is essentially real world life networks tend to be messy. And so any attempt to get at this thing called automorphic equivalence is really usually also a pretty good measure of regular equivalence. And that's doing violence to the math behind it. But that's the idea. And what it tells you is that if you're willing to take a fuzzy match on automorphic equivalence, which is what that algorithm does, then you actually have a lot more opportunities to do this on really big networks or any networks by just clustering people on any sequence of node level statistics that you can calculate quickly. And so this makes it possible to turn positional analysis from something that was sort of a cottage industry based on small network case studies into anything you want, really, that you can calculate. So long as we have now, thanks to all the growth in machine learning, really good tools for categorizing people with similar vectors. And so those tools applied to network involvement vectors should give you something approaching automorphic equivalence, which could really be useful and interesting. And we do some of that in the example. So I'm going to stop. There's a really fast version of the review. And I did that sort of deliberately for those that are, I assume that a lot of you had a chance to see it. But again, I'm happy to go back over any of that if people are interested. The main thing I wanted to do today was sort of expand on some of these ideas. And we got some really nice questions that were emailed to the Social Networks and Health group last night. One of which was to say, well, how does this rubric for connections versus positions differ from lots of other rubrics that are out there? And one of them is this notion that comes out of James Kitts in a recent paper that he put together that really tries to categorize social relations based on the thing that's happening on the edge, if you will. And so he makes up this distinction between behavioral interactions, interpersonal, which are, you and I talk together, or you and I share a meal or something, versus interpersonal sentiments, that is, I like you, but you find me annoying, right? So that's an interpersonal sentiment difference. Role relations are culturally loaded elements that are engaged in how people relate to each other. And then opportunities to interact or what I would assume are bipartite notions, opportunities for exchange, because we've shown up in the same space or something like this. And so how do these kinds of notions relate? Because could you have a role relation that's based on sentiments, for example? And my sense is that these are actually quite complementary. That it's the case that anytime you have, I think this is a great question, and I think there's a step back a second from a meta comment. Any rubric for organizing network analysis is probably going to fail, only because it's also a messy world designed to try to help us understand an even messier world. So I think that's fine. A rubric is as good as it is useful, and so I think take the useful parts and leave the others behind. But for my thinking, and this is my hammer and nail effect perhaps, but to my thinking, these things actually map onto each other quite nicely, in the sense that to the extent that the relation is the social effect driven by the relational configuration depends on one of these four ways in which the content of the relationship is shaped. That dependence is going to be driven by whether or not it's a connectionist effect or a positional effect. So, for example, if you think about sentiment as a core relation, who do you like, who do you hate, who do you trust, who do you distrust? Those kinds of relations define for each actor a set of others that are nicely put together in relation to me, right? So if I think of the people that I trust and believe and work closely with, and the people that I distrust and don't believe, so I have friends and enemies, and my enemy's enemy is my friend, so that's a classic role relation compound effect, right? So I think that oftentimes these things sort of nicely map onto this mostly positional versus mostly connectionist, and the distinction turns on this idea that behavior, whatever is going on in the network, has some effect on the individual, and that effect is either on the flow of something moving through it, in which case it's a connectionist effect, or it's in how they respond to the whole gestalt of the positional effect. Another great question that was asked was this idea of whether or not we have a lot of good tools for thinking about whole network comparisons in a connectionist frame, and these fall under the general rubric of centralization, or things like centralization, like density or something like this, or social cohesion. What's the analog for a positional model? And I like this question in part because I haven't spent a whole lot of time thinking about it explicitly. I left it implicit in my head. And so thanks for helping push me into thinking about this a little bit. But I think the main notion here is to think about macrostructural configurations. And in an ideal world, we could think of archetypes for those. And for this, I would probably go back to Eugene Johnson's work. Eugene Johnson had this really nice set of papers in the mid-'80s where he was asking, for a given set of triadic relations, what's the macrostructural necessity that set of relations implies? And that is, if everybody follows this rule that you can either be close friends or you can be isolates, so you can only have reciprocal ties or you can only have isolated ties, then the macrostructural network has to be block diagonal. It has to be this kind of effect. Now, what I like about this is that it doesn't say that every network in the world is going to have 4 blocks. What it's saying is that every network is going to have a block diagonal structure. And block diagonal structure is a characteristic signature of a kind of role system. And that's, I think, distinct from something like a ranked cluster system, where there are still communities. There are these communities, but there's also asymmetric relations, sentiment relations, probably in this case, between those who really like each other mutually and those who admire those that are, more popular than them. And so again, the ranked clustered structure, the extent to which a setting as a whole fits this bit, would be a characteristic of why one structure might be flatter in its hierarchy than another, is a way of thinking about some of these kinds of problems. And again, I can talk about those a great deal if people are interested. There are some other wider questions that sort of, if you get a chance to read the talk a little more in detail, you'll see that we go through and identify the ways in which you might use these to predict health. And the standard answer is these become variables in a general linear model. And once you go down that route, you bring with it all of the problems of non-independence that come with using network models in the general linear model framework. And so how do you deal with that, right? So I think the idea is that we don't really know very well yet. But one of the questions, and so we're doing some work now to try to figure this out. In general, your cases are not independent. And so your answers are, you either have corrected for the independence by bringing in these positional features. So that creates a conditional independence, which is exactly what you want, that is, you've specified the model correctly. Or it's the case that you've left something out, which has to do with non-independence, and is there another way to capture that? And in the presentation, we argue that the best way the general way is to add an autocorrelation term to it, and to the errors, just to test for it, and that seems to correct for simple kinds of autocorrelation. Whether or not, the bigger question that I think the questioner is asking here, which is really a good one, which is, if you have positional effects, do those subsume peer effects? And I think the answer is no. In most cases, you can have these things operating simultaneously. So it's the case then that as a father, I have a certain way of looking at the world and believing it, but then I also have a peer influence by the fact that I talk to other middle-aged men in my neighborhood who tell me what to worry about and what not to worry about. And so there's always simultaneously going to be peer effects and positional effects. And I think the extent to which these things matter is an empirical question. The problem, of course, is once you go down that road, you're going to open yourself up to saying, well, the only well-specified model is a kitchen sink model, and I don't think we usually want to do that. And so I think that often times positional effects, if a positional effect is not of substantive interest, and what your interest is because it's the thing you can control, or an intervention or something is a peer effect, then oftentimes controlling for something like your position in the latent space is probably a sufficient way to capture the error generated by ignoring positional effects while interrogating the substantive peer effect that you're interested in. So anyway, that was me. I already used all but 6 minutes of the time I was allotted for this session, and so I apologize for that already. Are there other questions that have popped up now that people had a chance to get reviewed on this?
Yeah, John asked, you'd be able to determine the difference between block and rank by looking at loadings on the triad census, or using something like page rank to get an overall measure of hierarchy?
Yeah, so I think that the answer is sort of. These are not really well-developed tools. The thing that that Eugene Johnson proposed is a metric known as the tau index, and the tau index compares the observed distribution of triad types to an ideal typical distribution of triad types, and then controls for the probability structure of the distribution of dyads in the network. You could do the same thing in an ergon by entering each of those proposed triad types as a separate model and asking whether or not the ones you expect to see are significant versus not, would be and then you could control for other underlying graph features, for example, descriptively. I think that the problem is the work that's been done since then on thinking about what are archetypical triad signatures or something. Hasn't been done. And so I don't, and it certainly hasn't been done for multi-relational networks. It hasn't been done for multi-layer networks. So there's a huge like group of work to be done out there to test for these kind of things. That said, my guess is that there are a handful of archetypical macro structures. There's core periphery, there's block diagonal, and there's sundry flavors of hierarchy. And then for multi-relational systems, you have all the work that's coming out of generalized exchange. So you have ring generalized exchange, you have chain generalized exchange, you have pooled generalized exchange. So we can think of a handful of, and I'm sure there are more that I'm just forgetting off the top of my head, but there are a handful of these archetypical structures. And then you could ask for each setting, you could do effectively a confirmatory component analysis, confirmatory factor analysis, say, does this network structure better fit a rank structure system versus a core periphery system? And you'd have to, because the field's not developed yet, you'd have to defend, how you do that test, but that would be the logic of the test.
Okay, Amy has a question that I think is really neat. To what extent or how does the approach to positional analysis change when using bipartite graphs?
Yeah, the beauty there is the system is, I think the short answer is not at all. It's the same approach to the problem. The difference is that you tend to have what defines the positions becomes a set of classes with respect to the other mode. So I have nodes that are, for example, that are bridges between kinds of modes that others don't set. So if you have people in meetings in the classic Southern women's data, there are 3 women that go to all the meetings. So they're the things that are they're what you might call bridges, whereas the other 6 women in that data set go to either the left partition or the right partition of the lunches that could be there. So there are some lunches then that play this dual role of being integrative and some that are exclusive. And so in that very simple system, the world breaks down into sort of a 2x2 of integrative and exclusive, and there are integrative events and there are integrative people. And now that's an incredibly simple system. And the beauty of the bipartite world is that you could end up with a partition of roles for events and a partition of roles for actors that don't correspond in that nice, neat, same way as it does in the Southern women's data. So it's going to be very different. Now, operationally, what do you feed it? The problem with bipartite networks is the triad census is kind of useless. So you have to go up to the 4-cycle census to make sense of it, because there just aren't that many interesting patterns of triads for a bipartite network. And so it might be faster to go to summary scores with respect to that automorphic equivalence trick, but it would be the same logic of the idea. Other questions or ideas? Yes,
Ben
Benjamin.
raised his hand. Yeah.
Please.
Is it me?
Yes, that's you.
Okay. Sorry. Yeah, I would like to circle back real quick to the question about whether positional effects can basically confound the relationship of peer effects or not, because like if we think of a network autocorrelation model, like the way you correct for the network in the error structure is really based on the adjacency matrix. So it is really like a connectivist idea. But like if there are like positional effects going on, I just wonder, I think someone should do some like simulations to figure out whether there are certain ways how positional effects can kind of appear as peer effects, or the other way around, depending on what you're interested in, really. For not controlling for one or the other, you will get biased effects. And I don't think that has been done yet, right?
No, it has not been done yet, though you're keying up. I'm happy to announce that Jeff Smith, John Morgan and I's number 3 in our paper series on measurement error in networks it's just been accepted to social networks. So we have a nice trio of, we refer to it as an album, and the third single has been released, and so that's been kind of fun. But the band is getting back together, and we actually have designed a whole series of experiments to do just this question. So what the plan is a new album where we go through a whole series of these different kinds of positional effects, peer effects, and error structures. The problem is it's a really difficult set of sets. So if anybody wants to jump in and start play with some of these models, please reach out, because the thinking is we do need to know this. Now, I am certain, just from the short amount of time I've played with this, that on the one hand, you're right. So it is definitely the case that if I have, if the real world is a peer effect on the error structure, an adjacency effect on the error structure, and a positional effect that has to do with something like information centrality, or any other kind of centrality that it's based on a radial model of flow as its feature, those two things will confound each other, because if you think about what's going on, is the centrality score is being built from the eigenstructure of the information centrality is an eigenvector family of centrality measures. And so it is pulling the adjacency of adjacencies into it. And so if you just model it without correcting for the error structure, or mistakenly run a pure effects model instead, you're going to get, both of those models will show significant effects, and you would interpret them differently, even though both of them are wrong by themselves. So I have no doubt that there are many ways to go wrong in this world, right? The question is, can you go reasonably not wrong without, because the last thing I want to do as a pragmatic analyst that's trying to help people get the work done is to say, what you need to do is specify every model with every possible centrality score and every possible autocorrelation effect, right? It's like, at that point, it becomes useless. And so there needs to be some way to classify, but sort of to get us from the world where it's possible to make mistakes, for which I think there are many, many ways to make a possible mistake, to figure out what's probably going on in the world. And I think that's going to require a bunch of investigation on the real world that we just haven't done yet. And everyone, Benjamin is the source of most of those questions that just came up. So thanks much to Benjamin for engaging on that.
There's one more question in the chat, if we have time, from Keith.
Sure.
Which is, could you also think of networks as controlling their members or as a reward for particular behaviors? Would this be subsumed under the role pipe distinction?
I think it probably would. So if you could imagine that essentially there are types of positions that in the classic role model of sort of effect, what a role does is it constrains my action. And what we do in the tradition of thinking about this is that the way that roles become solidified in social systems is through social sanctioning. And so if you behave inappropriate to your role, you get sanctioned by other members of the community. And so I think that does naturally emerge. And so for informal roles like leader and hangers-on and outsider and such, there are ways in which this can happen. And if there's, to the extent that there's any social reward or status that comes with occupancy of the set, then social sanctioning can be an effective tool. The problem is that some kinds of social control effects that happen within networks, people are trying to evade them. So if you think about teens and parents, like they get status by rebelling against parents. And so that counterplay means that the sanctioning has to come from the esteemed peers to be effective. I don't know if that helps or not, Keith.
That helps greatly, actually. Thanks.
Awesome, thank you. And I'd love to talk more about that. It'd be fun. All right, so I yammered on past my time. Though I guess I'm only stealing from myself and from John. So, but let's take a quick break just so people can refresh their coffee. It's 10:34 now. Let's come back at 10. Let's come back at 10:40. So we'll just take a 5-minute. We'll just push off, or we'll keep our 5-minute break and push off. And we'll see you back here at 10:40 Eastern time.